Hey guys, let's do some MCAT math. So here's a question. In order for an airbag to inflate, sodium azide is decomposed according to the balanced reaction shown below. If 2.25 moles of nitrogen gas are needed, how many grams of sodium azide must be stored in an airbag? I'm going to quickly just go over the setup for this problem, but I'm going to spend less time on that and more time on how I would recommend doing the math. So we have, let's say, yeah, we have a step one where what we do is we take what's given, which is the 2.25 moles of the nitrogen gas, and using the balanced reaction, we can see that there's a 3-to-2 ratio of the nitrogen gas to the sodium azide. So we want to figure out how many moles of sodium azide we get, and then we use our gram formula mass to figure out the actual mass of that sodium azide. Now, so what this will involve would be first the conversion, or first us figuring out how many moles of sodium azide there will be. So we know that there's 2.25 moles of N2 gas, and we can use the balanced reaction to see how many moles of sodium azide that will convert into. So we know that for 3 moles of N2 gas, we get 2 moles of sodium azide, NaN3. And when we multiply these out, the moles of nitrogen gas cancel. So we have in our answer something that will be in moles of sodium azide. So now the question is, how can we do this math? This math of 2.25 multiplied by 2 divided by 3. Now, what you can do is, or what a lot of people would say would be to round, but I haven't seen other people do it this way, but the best way to do it would be to use fractions. So let me show you how that would work. So this 2.25 is 2 1/4, right? That's written as a mixed fraction. Now, to convert so we want to convert the mixed fraction into an improper fraction. So what we do is we take the denominator 4, we multiply it by the larger number 2 to get 8, and then we add it to the numerator to get 9, and then we divide it by the same denominator. So this turns into, so 4 times 2 is 8, plus 1 is 9. 9 divided by 4 is what 2 1/4 will be equal to. So instead of the 2.25, I would use 9 over 4. Now, let me show you why. Because I can now, since I'm multiplying it by 2 over 3, I can do this. The 2 goes in to the 4 twice. The 3 goes into the 9 3 times. So this is 3 over 2, which is 1.5. So that's how I would do that. Now, let's think about that next step. So the next step involves, so this 1.5 is the number of moles of sodium azide. Now, to figure out the grams of sodium azide, we use its gram formula mass. So, you're gonna have to pull up your periodic table for that, but I'll just tell you the mass would be 65 grams per mole of sodium azide. And we can multiply this by the number of moles of sodium azide that we have, which is the 1.5 moles of sodium azide. Now, 1.5 times the 65, how do we do that? Well, what I would do again is to use a fraction. So, and this usually helps if the number after the decimal point is a 5. So I would do like, what's 1.5 times 2? It's 3. So 1.5 is equal to 3 over 2. So here, instead of this 1.5, I'll write 3/2 times the 65. And 2 goes into the 65. I mean, 2 goes into 64 just like 31 times or so, right? So let's say like whatever, 30. And then 3 times 30 is 90. And, we know our answer should be a little bit higher than 90 because I rounded down here. So that brings us essentially to our answer of 97.5 grams. So that's a little bit of a math trick there. So hopefully that's useful.